Hello everybody, welcome to my tech talk. Today I'm going to give you a very brief introduction to game development with Unity 5. Hopefully I can pick your interest a little bit, so let's get started. So what is game development? Game development is the software development process by which a video game is produced. Someone say what an is, but some other people may say, so how is a video game really produced in the real world? So to answer that question, so I will give you an introduction to a very powerful tool called Unity 5. So Unity 5 is the latest release of a feature-rich and highly flexible game engine that supports 2D and 3D graphics, drag and drop functionality, and scripting through C#. The good news is it's free. Personal plan is free and has all core features of the Plus and the Pro plan, which is charged by the company. In the following section, I want to give you three main features about the Unity. The first one is lighting. So what is lighting? The lighting is a large composition of graphics in Unity in order to calculate the shading of a 3D object. The Unity needs to know the intensity, direction, and the color of the light that falls on it. So basically, the stronger the light, the lighter the game object is. The surface of game object is lit according to where the light is coming from. And then the color of the game object itself is calculated based on the color of the light and itself. So there are three lighting techniques in Unity. The first one is the real-time lighting. I don't include it here, but I will talk about briefly here. The second one is baked light maps, and then the third one is pre-computed real-time global illumination. So what is real-time lighting? Real-time, by default, lighting in Unity is real-time. They have the form of directional, spot, and point. The baked light maps are the calculation of the effects of light sources on a static object. It included both the direct light that strikes the surface and the indirect light that bounces from other objects or the surfaces within the scene. The pre-computed real-time global illumination is a mix of both real-time lighting and baked light maps. It can be real-time and also has the bounciness effect. And a good example of this is a good example of pre-computed real-time global illumination is a system of daytime systems, where the position and the color of the light changes over time. You can see on the picture right here. The next thing I want to talk about is the physics aspect of Unity, which is something called colliders. So the collider components define the shape of an object for the purposes of physical collision. You can think of a collider as a network of sensors around game objects. When two colliders interact with each other, the on-collision enter 2D function gets triggered, sending a message to the physics engine in Unity, telling the physics engine to execute some certain functionality. So, and then another feature of collider is the collider does not need to be the exact same shape as the object's mesh, and in fact, a rough approximate is often more efficient and indistinguishable in gameplay. What does that mean? Well, basically it means that the sensor, which I will talk about earlier, does not need to be closely attached to game object itself. It can be in the approximate area where the game object is in it. So when a collider, when one collider enter into the area, enter the zone of another object, so the collider gets triggered, and then the on-collision N2D function gets triggered and sending the message telling the physics game engine that I need to execute some certain functionality, so that creating some of the collision effects. So this is a collider interaction matrix. If I were a game developer, if I want to create some collision effect based on the chart, I can choose a rigid body collider, and then along with another static collider, which will have the collision effect. Or if I don't want the physical collision happen in my gameplay, I can choose, for example, I can choose a static trigger collider meeting with another rigid body trigger collider, for example. And then someone may ask, what is the trigger? The trigger is something that physics engine in Unity will ignore. Basically, when I set a trigger on an object, that object doesn't have any physical effects on when something when something is hitting the game object itself. It will basically bypassing that. For example, if I drop a ball to the ground, and then if I set the ground as a box collider, instead of bouncing the ball back, and then the ball will go in through it. So which will basically ignoring any physics in the real world. And then the last feature I want to talk about is something called scripting in Unity. By default, Unity uses mono development to allow game developers to write some scripts alongside with the Unity interface. So mono development is an open source integrated development environment for Linux, Mac OS, and Windows that supports tons of languages, C language, Visual Basic .NET, and C#, and so on. In Unity scripting, there are a number of event functions that get executed in a predetermined order as a script executes. So I think this is the very briefly picture of that. But the core concept is very simple. Once the game plan starts, the awake function gets triggered, followed by the any physics function, which we are calling some physics function to get executed, passing the message down to the physics engine in Unity, and followed by the start method, which will be only called once per game, and then followed by the update method, which will be called once per frame. This is the example I want to give you. I want to present to everyone here. So, for example, if I have 3 scripts, I have I have 2 music player scripts and 1 level manager scripts. Basically, the start method in the first music player script doesn't get executed until all 3 awake function gets executed first. Basically, in the C# or Unity scripting world, there's no concept of asynchronous. The operation is synchronous. So one function is executed before another, so on and so forth. And then there's a way more components and features the Unity can cover than I can talk here. So for some famous one, maybe the particle system, animation, materials, and audio. They are all the very well-known features of Unity. So if you want to dig into deeper, I include some of the Unity official site, a download link for everyone to take a look at that. And they also made a very good tutorial on the Unity website, so everyone can just go on the website to check it out. So I think this is right now is a very good time to make a game with Unity. So thank you for listening, everyone.